basically, Friedel-Crafts reaction is when you want to introduce a side chain into a benzene ring, okay? So this is the basis of an electrophilic substitution reaction. The idea is you want to attach something to the benzene. For halogenation, you want to attach halogens to the benzene ring. For nitration, you want to attach the nitro group, the NO2, to the benzene ring. For alkylation, you want to attach the alkyl group onto the benzene ring. Okay, it's not reflecting what I'm doing on my, okay, alkylation, right? So in order to attach an alkyl group, you need obviously the alkyl group that you want to attach. In this case, it's the CH3 that I have just circled there. And that CH3 must be attached to a halogen. Usually we use chlorine, okay? An acyl group is when you have a carbonyl, C double bond O, and an alkyl group, ethyl, methyl, propyl, butyl, and etc. Right? So this whole blue blue group that I've shaded in blue is an acyl group. So if I want to attach that acyl group, I have to connect it to a chlorine. The reason for this is the formation of your electrophile. Okay, only with chlorine that you can form a positive electrophile of your acyl group because of your catalyst being a halogen carrier. It matches with the chlorine on your reactant. Okay, so one thing that I want you to take note of is that when you attach your acyl group to the benzene ring, you are connecting it onto the carbon of your carbonyl, C double bond O, not CH3. Okay, so where that green bond is, that of your chlorine, that will be broken in the first step, which is the formation of electrophile. And then that is also where you will forming your new bond with benzene. Okay, so this is the first step, which is the formation of the electrophile. This step is present in all the reactions that all the mechanisms that we have looked at so far, like halogenation and nitration. It's just that it's slightly different in terms of reagent. Okay, catalyst is the same for halogenation and Friedel-Crafts, but for nitration, the catalyst and the reagent is a bit different. Okay. So you form a positive electrophile. Usually electrophile tends to be positive, okay? So these are the ones that will be attacked by the benzene ring. The next one, the attack, is again, nothing new for you, right? Just please take note where the attack is happening, okay? It is on the carbon that has 3 bonds, right? As for your acyl group, same thing, it is at the carbon with 3 bonds. So the electrophile will not attack the carbon of your alkyl group. If you look at this carbon that I've just highlighted, that carbon already has 4 bonds. It's happy, you do not disturb it, okay? And then it's the regeneration of catalyst. Okay, moving on, now we're going to look at the oxidation of the side chain. Okay, right, so before we start oxidation of the side chain, I would just like to recap on the fact that alkanes cannot be oxidized. Okay, if you go back to your AS syllabus, alkanes cannot be oxidized by an oxidizing agent. However, when your alkanes sit on a benzene ring, okay, they can be oxidized. Right, so there's a change in behavior once you start attaching your alkanes onto the benzene ring. So we call this an alkyl arenes. Okay, this alkyl arenes means you have an alkyl group, which is your CH3, and then your arene is the benzene ring. Now, arene is a functional group, and benzene is the simplest functional group. So in alkyl arenes, the side chain, which is the alkyl group, can be oxidized. Okay, when they are oxidized, they form carboxylic acid. So you can see that there's the change in CH3 to COOH. Okay, so this product benzene with a COOH is called, we've come across this already, it's called a benzoic acid. Okay, so that's a transformation. The reagents and conditions, you need to use an oxidizing agent, which is the famous one that you've used, is the potassium manganate. Okay, it has to be an alkaline form. So that means you need a sodium hydroxide. Okay, alkaline potassium manganate, and then you heat it under reflux. I hope you still remember what heating under reflux means. If you don't, then you have to revisit your topic alcohol. Okay, right. After you've added the potassium manganate and sodium hydroxide in alkaline condition, you heat it, and then only you add sulfuric acid. Okay, you want to acidify your product. Now, you notice this number 1 and 2 because they are arranged in sequence. That means you have to add number 1 first and then you add number 2. Okay, you cannot add alkaline and acid together because otherwise they would just be neutralized. Okay, so you have to do it separately and you have to number them. Yes, when they ask you to write down the reagents and conditions to oxidize your alkyl benzene or alkyl arenes, it has to be numbered. Because if you don't number them, if you just write them, alkaline potassium manganate, acidified sulfuric acid, this means that you are adding everything together, which is wrong. Okay, so please take note of the number. So when we write the equation, we do not write potassium manganate SKMnO4. We write square bracket O to show that it is an oxidizing agent. As you know, during an oxidation process, you are gaining an electron. Okay, so your CH3 will become COOH. Right? Your benzene is unaffected because the one that gets affected is the side alkyl group. Okay, alkane will not be, if it's alkane without the benzene ring, they cannot be oxidized at all. But when this alkane is attached as a side chain onto your benzene ring, they can be oxidized to a carboxylic acid. So the product we call is a benzoic acid. Okay, the other product is water. Now, interestingly, any alkyl group will give you the same product. Whether you use a methyl benzene, a propyl benzene, an ethyl benzene, butyl benzene, you will still get the same benzoic acid with one carbon, COOH. Okay, so this is a special thing about this oxidation. You can use a very long chain of alkyl group, you will still get a benzoic acid. Okay, your condition, as you can see, it's written as A and B. Alkaline potassium manganate, don't forget to add reflux. Reflux means heating. Okay, it's a special type of heating. And then you add dilute sulfuric acid to acidify your product. Okay, now this is not the balance equation, as you can see. So I leave out the balance equation because it's a little bit more difficult to balance. As you can see on your product, you have 6 plus 3, 9 carbon, and then in your reactant you have 9 carbon, but in your product you only have 7 carbon. Okay, so don't worry about balancing the equation. So the most important thing is that you need to remember whatever alkyl group you have, your product will always be benzoic acid. Okay, so that's one of the interesting things about this oxidation of your alkyl side chain. Next, we're going to look at the hydrogenation of the benzene ring. Just like your alkenes with a double bond, you can hydrogenate them. Okay, you can add hydrogen, or we say that this is a reduction. Okay, remember when you accept hydrogen, it's a reduction process. So we call it hydrogenation. It works just like alkene. Okay, so hydrogenation is an addition reaction in which hydrogen atoms are added around the benzene ring until all of them become a single bond. Okay, you will form a cycloalkane. So what happens during hydrogenation? You're actually breaking the delocalized system completely. You break all the double bonds inside the ring. Now, before we look at the product, you need to remember that this carbon, they're not, this benzene ring, they're not drawn, but they contain hydrogen bond on each carbon, like that, okay? So in the product, I will draw the original hydrogen first. How do you draw the product? Just remember that all the double bonds are broken and only you will see single bonds, okay? So if you look at one carbon, this carbon is attached to 3 bonds. That means there's one available bond, okay? So that available bond is actually for your incoming new hydrogen, okay? So I'm going to use purple. Now I'm going to add my hydrogen onto my product. So that's 1 hydrogen. So each carbon atom can accept 1 new hydrogen. Okay, so this product is called the cyclohexane. It is no longer an arene functional group. Okay, it is now an alkane. It is a cycloalkane. Okay, that's why you see the name ending with "ane", just like your normal alkane. Okay. Right, how many hydrogen have you added? You have added 6 hydrogen, which is the purple one. So that means to balance the equation, you need 3 H2. Okay, likewise for the second example, oh, sorry, I forgot to mention, the reagents and conditions, the catalyst that you need, the reagents that you need is the hydrogen molecule, H2. The condition, the catalyst is a nickel catalyst, which is the same as your, more or less the same. I think for double bond, you can use platinum or palladium, yeah, or nickel. And then the temperature is 150 degrees Celsius. Okay, for methyl benzene, same conditions, same reagents. Okay, we just have to know how many hydrogen is needed. So initially, you have hydrogen on 5 carbons only. I hope you can see that. Okay, this carbon already has a methyl group, so you will not have a hydrogen there. The hydrogen has been substituted. Okay, so I'm going to draw the hydrogen first, and then my incoming hydrogen will be purple. Oops. Okay, so my purple hydrogen. Now look at this carbon. This carbon only contains 3 bonds, so it can still accept a new hydrogen, okay? Because carbon can form 4 bonds. So 1, 2, 3, 4, 5, 6. Okay, so this is called a methyl cyclohexane. So there is a change in functional group, okay? You go from an arene into an alkane, okay? Right, so that is all for this, what's that? Cancel. For this topic, okay? Is there any questions that you would like to ask?
What if other alkyl group attached to the benzene?
Okay, other alkyl group attached to the benzene. And then you're asking about hydrogenation, is it?
Yes.
Okay,
For example, ethyl benzene. Is
ethyl
it
benzene.
same as the
Yeah,
methyl benzene?
same. So ethyl benzene would be, if I write it down here, C2H5. Yeah, same. Okay, because the alkyl group is just the side chain. The most important thing is you are adding hydrogen into the ring. Okay, so that means the number of hydrogen that you're adding here, if you count the purple hydrogen, 1, 2, 3, 4, 5, 6, that's 6 hydrogen. So you need 3 hydrogen molecules. Okay. Any more questions before we move on?
What if there is electron donating or electron withdrawing?
No effect, because all the positions
No.
will get the hydrogen. Okay, so when you have an electron donating or electron withdrawing, as you know that they usually activate certain position, but in this case, it does not matter because all the bonds will be broken, so all your carbon will get a hydrogen. Okay, so the electron withdrawing or electron donating is only especially important for your electrophilic substitution reaction. Okay, so this is a hydrogenation, so that activating position doesn't play a role here. Okay, right. Now let's move on to your exercise 15.1. Okay, can you please take out your exercise 15.1? Let me just share this again. Okay, let me stop sharing first. Okay, you've got your exercise 15.1 with you?
Yes.
Okay. Hold on, yeah. Okay, so the first question, briefly explain why the benzene molecule is planar. Okay, so this is regarding the structure and bonding of your benzene. Okay, now if you saw earlier on, you remember that the carbon is hybridized. Okay, the carbon is hybridized sp2. So this could be a reason. There's only one mark for this question. Oopsies, what did I do? Okay, so one mark for this question. So to answer that, you don't need a lot of explanation. You can either say because the carbons are sp2, or you can talk about the shape. Do you remember the shape of the benzene ring? The shape on each carbon inside the benzene ring? What's the shape? Hello? Anyone?
Trigonal planar.
Correct, trigonal planar. So because it is a trigonal planar, so the name planar already suggests that it would be a flat or plane molecule, a planar molecule. Okay, so there are a few accepted answers here. Okay, you can choose one of them, or you can say that the carbon are bonded at 120 degrees. Okay, so the fact that you know that the bonds are arranged at 120 degrees, it should tell that it is planar, flat. Okay, unlike tetrahedral 109.5, it's not a flat molecule. Some of them will come out of the board, some of them will go into the board. Okay, briefly explain why all the carbon-carbon bonds in benzene are the same length. Now, calculate structure said that, can I draw? I can't draw things here. Calculate structure said that benzene contains a single and double bond, alternate, okay? Alternate single and double bond. But then it turns out that the bond is not single. When they calculate the length, bond length, it's not single, and it's not also double. So it's in between. Okay. The reason for this is because the double bonds is not fixed. Okay. The double bonds are delocalized. So that is the reason why the bond length in benzene ring is the same when Kakule said 3 of them should be single bond, 3 of them should be double bond. Okay, the double bonds are delocalized. Or you can see, you can say the pi electrons are delocalized. So that's again another 1 mark. Okay, so in total you have 2. Okay. Next one, both ethene and benzene react with bromine, but the mechanisms and the types of products of the two reactions are different. Okay, so this is an alkene, this is an arene or benzene. So you will have to go back to your AS notes. Now, I will not give you the answer. I will give you hints only. Please write down these hints and then use your notes later on. Okay, so alkene is an AS topic. So you will have to go back to your AS topic, find the name of the mechanism for the reaction between alkene and bromine. Okay, for benzene and bromine, I hope you still remember. We just covered this like last week, or I have been mentioning it to you a couple of times already. Okay, so that's the name of the reaction. The next one is the intermediate. So again, you have to look at the mechanism. Okay, so they want you to, in each of the following boxes, draw the intermediate and use curly arrows to show how it is converted in the product. Okay, so I'll let you do this again on your own, because otherwise, you will never look at your notes. So this is so both of them will have a carbocation intermediate. So that's what you have to draw. Carbocation intermediate. Carbocation means there is a positive charge on the carbon. Okay, so that's what you have to draw here in the intermediate, and then follow your notes, draw the arrow. Okay, show the mechanism. You have to show the mechanism. Use curly arrow. Use curly arrows to show how you form the products. Why do ethene and benzene differ in their reaction with bromine? Okay, let's see. Obviously, both of them have different mechanisms. Okay, but the reason why benzene is different from ethene or any other alkenes is the double bond is not the same. Okay, in alkenes, the double bond is localized. That means it's fixed. In benzene, the double bonds is delocalized. That means it moves. Okay, so to answer this for 1 mark, we will say the delocalized ring of electrons in benzene is stable. Okay, or you can say electrons in the pi bond of ethene is localized. So it means different things. Okay. Localized means fixed. Delocalized means it's not fixed. It moves. Okay. Another thing is that the delocalized system, the ring, is stable. So that means you cannot lose the delocalized system. You have to reform the delocalized system. Okay. Question 3. Are you all okay? Now, I don't expect you to answer them now, but just follow me through these hints, okay? And write down the hints so that it's easier for you to do these questions later on, okay? Just a reminder for those of you who have not handed in question 3, 5, and then I think it's 6, 7, 8, if I'm not mistaken. Please hand it in, okay? I've started marking, and I noticed that some of you have not handed it in. Please hand it in, because now we're going to do exercise 15.1. So your work will add up if you don't, or if you haven't done the previous exercise, okay? Right, question 3. Are we okay to start with question 3? Can I hear your voice saying that you're okay?
Yes.
Miss.
Okay, good. Thank you. Thank you so much. Right, so this question is concerned with state the conditions needed to produce the two components A and B. Okay, right. So your starting point is here. That is your starting point. Okay, you have a methyl benzene. Now let's look at reaction 1 first. What happens is that you are adding chlorine onto the benzene ring. Okay, so that's your first hint. Your reaction is in the benzene ring. Okay, so you need to know the mechanism that is associated with benzene, right? Reaction B, your chlorine is added on the side chain. That side chain is an alkyl, and it is an alkene. So that means you have to look at the reaction at alkyl side chain. Okay, you can find this from AS or from your notes in this topic, right? If you know where to find this, you can find the conditions and the name of the mechanisms for this in your current topic, topic 15. Okay, otherwise, you can also go to your AS topic, alkane, because it's alkyl is a type of alkane. Okay, so please use that hints to help you. Conditions. Conditions means you need, the reagent is already given to you. If you look at this chlorine, that is your reagent. Okay, so the conditions means catalysts or any other condition like heat, light, I don't know, something else. Okay, so you don't have to write down Cl2 because Cl2 is already there, which is your reagent. So they want other things like catalysts or other things. Yeah, I don't want to say it, otherwise I'll be giving you the answer. Okay, moving on. Question 4. I have 7 minutes left. Okay, so you need to find the reagents and conditions. So they're quite straightforward if you know where to find the answer. Okay, basically you want to convert benzene into chlorobenzene. Chlorobenzene is when you have a chlorine attached to your benzene. So this is a halogenation reaction. Please write down the reagents and conditions. Okay, so hint for you is halogenation. This is in topic 15. The next one is from benzene ring to a bromobenzene. Again, a type of halogenation, but you just have to change your reagents into bromine. So you change your catalyst into something that is suitable for bromine as well. Okay, this is all in your notes. All you have to do is to learn how to use your notes to help you get the answer. Last one is nitrobenzene. Again, nothing difficult. Nitrobenzene is when you attach a nitro group, NO2. Go to your notes to find nitration, the conditions and the reagents of nitration. Okay. And then the nitration of benzene is a two-step reaction. Identify the cation A. So you have to look at the mechanism of nitration. Cation A is your electrophile. Okay. B, your intermediate, is what happens when your benzene attacks your electrophile. Draw the structure of the intermediate B in the box. Okay, I'll leave that for you to do. Simple questions so far. Okay, so I want you to do from question 1 to question 4. I've helped you with most of the hints anyway. Okay. Oh. Is it not mirroring my? Why is it not showing you anything? Okay, that is weird. Hold on. Okay, that is something that you should have seen. Okay, so please next time if you don't see anything, let me know. Otherwise, I will just continue and assume that you can see everything that I'm writing. Okay, so I have written this down, which you were not able to see just now. Okay, this is what I have written down. And the other one that I have written down is this, which you did not see. Okay, so there's some hints. On question 4, the A plus is your electrophile. Okay, the intermediate B that you have to draw is what happens when the delocalized system attack the A plus, right? So I'll let you copy this first for 1 minute because we have 3 minutes left. So 1 minute, copy this down. But you know, again, it should not be difficult because everything is in your notes. Okay, going back to page, sorry, question 3. This is what you should have seen just now, what I'm explaining. Okay, so please next time, if I'm talking but it looks like nothing is appearing on my screen, please let me know because just now actually you know, I was writing, but it didn't come out. Sometimes, yeah, Zoom does that. Okay, so please make sure you know that this is your starting point. Okay, and then you add your reagent chlorine. Okay, your chlorine is attached onto the benzene ring, so that means it has to involve the reaction on the benzene ring. Okay, here chlorine is attached to the alkyl group, so the reaction is relating to the alkane or alkyl side chain. So you have to look at the mechanism of alkane. Okay, I have less than a minute left, so I will just stop